You look at your roof on a hot July afternoon, and what you see is a row of dark, silent glass panels baking in the sun. You probably paid $4, $5, maybe $6,000 for that setup. Or worse, you signed a 20-year lease that ties your property to a utility company by a different name. You were told it was the only way. That clean, independent power had to come from a silicon cell manufactured in a high-tech cleanroom halfway across the world, managed by a computerized inverter that will likely throw an error code and fail before the decade is out. Every winter, when the gray overcast settles over the hills for 3 weeks straight, and the snow covers those panels, you watch your meter spin backward into the utility's pocket anyway. Stop and think about that. We have been trained to believe that self-sufficiency is a luxury available only to those who can afford a 5-figure tech investment and a subscription to a licensed technician. But if you walk with me down into the wooded hollows of Holmes County, Ohio, past the neat white farmhouses where the power lines simply end, you will find something else entirely. You will hear a low, rhythmic whirring, a sound like a soft wind through dry corn tallgrass. It comes from an ugly, grease-smeared drum made of 2 pieces of salvaged plastic auction barrel, bolted to a length of scrap steel pipe and mounted right on top of a common fence post. It costs less than $200 to assemble from things most men throw away. There are no microchips in it. There are no rare earth elements. Yet, that single spinning drum hums along in a 6-mile-per-hour breeze, night and day, winter and summer, feeding a steady stream of amperes into a bank of ordinary golf cart batteries. It runs the LED lights, the well pump, and the chest freezer of a family of 7, without a single wire connecting them to the outside world. I have seen these machines working with my own eyes. Last autumn, I stood in the workshop of an Amish builder named Eli while a cold drizzle beat against the window panes. He was using a simple hand wrench to tighten 2 zinc-coated nuts on a salvaged treadmill motor, the kind you find on Craigslist for $40 every day of the week. In less than 11 hours of total work, spread over 2 evenings, he had built a machine that hums through ice storms that would crack a modern solar panel to pieces. Understand this, though. I am not promising you a magic engine that will power a 5-bedroom suburban home with central air conditioning running at 68 degrees all summer. This method has an honest limit, and we need to be clear about it right now. Yours lifestyle requires resistance heating clothes dryers, electric water heaters, and phantom loads from 20 different appliances left on standby. This machine will fail you. It is a tool for a different way of living, one that values resilience over excess. It produces 400 to 600 watts of continuous power in a normal breeze. In the language of the grid, that sounds small. But when you strip away the waste, that small stream of current is exactly what stands between an independent homestead and a monthly bill. This is not some folk superstition or a crude backyard experiment. The basic physics of this design goes back to 1919, when a German physicist named Albert Betz proved exactly how much energy a moving fluid can surrender to a mechanical rotor. Modern science hasn't changed those laws. In fact, if you dig through the archives of the United States Department of Agriculture, you will find Farmer's Bulletin number 1394, published back in the 1920s. The government spent thousands of dollars detailing how any homesteader with a wrench and a weekend could build a direct drive generator to light his barn. That knowledge didn't disappear because it stopped working. It disappeared because a centralized utility company cannot send you a monthly invoice for the wind that blows across your pasture. Why do we pay for electricity every single year? Month after month, when our grandfathers understood that the air moving over a ridge is a free, mechanical force waiting to be harnessed. How did we let a century of practical, repairable wisdom be replaced by a glass panel that cannot be fixed with a screwdriver? The secret lies entirely in the geometry of the harvest. When you look at a solar panel, You are looking at a static surface trying to catch photons at a specific frequency. When the sun goes down, or the clouds move in, the harvest ends. A vertical axis drum, however, treats the wind like an endless river. It doesn't care which way the breeze is blowing. It doesn't need a 60-foot tower braced with expensive guy wires. And it doesn't stop working when the sky turns dark. It takes the kinetic energy of the atmosphere, something as simple as the draft created by a weather front, and turns it into rotational torque. If you take a close look at how these pieces actually fit together, how a simple piece of curved plastic interacts with a magnetic field inside a discarded motor, the whole illusion of complex modern engineering begins to break down. You realize that you don't need a factory in Asia or a government subsidy to become energy independent. You just need to understand the relationship between a hand-cut curve and a copper coil. Let me show you the actual layout on my workbench, and how those two pieces of plastic are split down the center to create the exact pocket needed to catch the air. Step closer to the bench and look at this drum. What we are building is a 3-vane, vertical axis rotor, often called a lens design. The beauty of this shape is that it doesn't need to turn into the wind like a traditional windmill. It catches the breeze from any direction simultaneously. Your first task is selecting the core of your machine, the generator. You are looking for a permanent magnet DC motor, specifically one pulled from a junked treadmill. When you scout for these at estate sales or scrapyards, look for a heavy, cast iron or thick steel casing, usually painted a matte black. Smell the rear cooling vents. If you catch a sharp, acrid scent like burnt hair, the armature has overheated and melted its insulation. Leave it where it sits. What you want is a clean, metallic smell with just a hint of old machine oil. Read the label carefully. You need a motor rated for at least 90 to 130 volts DC, with a low revolutions per minute rating, ideally under 3,000. Why? Because a wind turbine spins slowly. If a motor needs 5,000 RPM to make 90 volts, it will sit dead on your pole during a gentle breeze. A low RPM motor will start pushing 12 to 14 volts into your battery bank when the drum is only turning at a modest clip. The most common mistake beginners make right here is trying to use an ordinary alternating current motor from a washing machine or a table saw. Stop and understand this. Those motors require electricity from the grid just to magnetize their internal rotors before they can generate a single watt. A treadmill motor contains strong, permanent ceramic magnets. The moment the shaft turns, even by a fraction of an inch, electrons begin to flow through the copper wires. It requires no outside permission to start working. Now, let us handle the vanes. We use a 55-gallon food-grade polymer drum, the bright blue or forest green variety that usually holds cider or vegetable oil. Avoid white drums. They lack UV stabilizers and will become brittle, cracking like dry eggshells after a single summer in the sun. Take a handsaw or a jigsaw with a coarse blade. As you cut through the thick plastic, you will smell the faint, sweet aroma of whatever foodstuff it once held, and the blade will throw off curls of plastic ribbon that feel warm and slightly waxy to the touch. You need to split the barrel cleanly down its length into 3 equal sections. Here is where geometry matters, and where a lot of men ruin their first build. If you simply bolt these curved pieces flat to your support flanges, the wind will hit them and stall. To create lift, to make the drum spin with force rather than just drag, each vane must be mounted with an offset. We use 2 round plywood discs, 3/4 of an inch thick and 24 inches in diameter, cut from marine-grade fir to serve as our top and bottom end caps. Coat them in 3 layers of dark, pungent linseed oil to seal them against the rain. On these discs, you will mark 3 lines radiating out from the center, exactly 120 degrees apart. Slide the inner edge of each curved plastic vane 4 inches past the center point, creating an intentional gap along the central shaft. This gap is the secret to the machine's efficiency. When the wind hits the open cup of one vane, The air doesn't just trap itself. It slips through that central opening and pushes against the backside of the opposite vane on its return trip. It is a continuous self-feeding cycle. To connect the wooden end caps to the motor, you need a hub. Go to a farm supply store and buy a common 2-inch floor flange and a length of threaded black iron pipe. Clean the pipe with a rag soaked in mineral spirits to remove the sticky gray storage grease. Screw the flange onto the pipe until it is tight enough to draw blood. Then bolt that flange directly to the center of your bottom wooden disc using zinc-plated carriage bolts. The top of your iron pipe must now couple with the shaft of your treadmill motor. Most treadmill motors come with a heavy threaded steel flywheel attached to the shaft. Do not throw this away. It is your foundation. Take it to a local machine shop, or, if you have a steady hand, use your own drill press to sink 3 holes through the flywheel face so you can bolt it directly to your upper wooden disc. When you align the motor shaft with the central pipe, everything must be perfectly concentric. If your center point is off by even 1/8 of an inch, the turbine will develop a rhythmic, destructive wobble at high speeds. It will sound like a heavy boot tumbling in a clothes dryer, and within 3 months, that vibration will chew through the sealed bearings inside your motor, rendering your hard work useless. Take your time with a tape measure. Measure twice, mark with a sharp awl, and drill slowly. Once the mechanical assembly is solid, lift it by the pipe. The drum should rotate smoothly with the touch of a single finger, completely silent, with no scraping or dragging sounds. Now, look at the 2 wires coming out of the motor base, usually a red one and a black one. This is raw, unregulated direct current. If you connect these wires directly to a battery, the turbine will charge it when the wind blows. But the moment the breeze stops, the process will reverse. The battery will feed power back into the motor, turning your wind generator into a very expensive, very slow-moving fan that will drain your storage bank before dawn. To prevent this, we introduce a simple blocking diode or a basic 20-amp charge controller into the line. This acts as a one-way valve, allowing electrons to climb up into the battery but blocking them from crawling back down. As you prepare to mount this unit to your fence post or garage eave, you must consider the connection to your battery bank. Do not use thin, brittle extension cords. You need thick, copper welding cable, at least 10 gauge, wrapped in tough rubber insulation. When you strip the ends, the copper should look bright and clean, like a new penny. If you use thin wire, the resistance will turn your hard-earned electricity into useless heat long before it ever reaches the cellar. The turbine is now assembled, sitting on your bench, ready to face the elements. But before we carry it out to the ridge and raise it into the airflow, we must understand exactly how to prepare the battery bank that will receive this power, and how to tame a storm when the breeze turns into a gale. Now that the drum is balanced and the wires are prepped, we need to pause and look at what is actually happening in the air around us. To get the most out of this machine, you have to understand the invisible forces at play. Think of moving air not as empty space, but as a heavy flowing river. Air has mass. A cubic yard of it weighs about 2 pounds at sea level. When a weather front moves through your valley, that river of air carries a massive amount of kinetic energy. Our blue plastic drum is simply a mechanical trap designed to intercept that moving weight. Because this is a vertical axis machine, it relies on 2 competing principles: drag and lift. Imagine holding an open umbrella into a stiff breeze. The wind catches the hollow interior and pushes you backward with tremendous force. That is drag. Now imagine walking through water and turning your hand sideways so it glides smoothly through the current, slicing it in 2. That creates lift. Our barrel rotor does both at the same time. When the wind hits the open, hollow side of one split drum, it treats it like that umbrella, dragging it forward. But because of that 4-inch offset gap we measured on the workbench, the air that slips through the center flows over the back side of the next drum. The curved outer surface acts like the wing of an airplane. The air moves faster over the outer curve than it does through the inside, creating a pocket of low pressure. This low pressure literally sucks the trailing vane forward into the wind. By combining the raw power of drag with the efficiency of lift, this simple plastic assembly overcomes the single greatest flaw of older vertical axis designs: the tendency to stall out. It is a beautiful, self-sustaining loop of fluid dynamics hidden inside scrapyard materials. But we must be entirely honest about the math and the limitations of this machine. There is a rigid boundary in physics known as the Betz limit. In 1919, Albert Betz proved that no wind turbine, no matter how perfectly engineered by a corporation or a farmer, can capture more than 59.3% of the kinetic energy in the wind. If you tried to capture more, the air would completely stop moving behind the blades, blocking the incoming wind like a solid wall. A high-tech, multi-million-dollar utility turbine with 70-yard composite blades operating in the North Sea hits about 45% efficiency. This homemade drum, built with a draw knife, a handsaw, and a used treadmill motor, operates right around 30 to 35% efficiency. Stop and understand what that means. You are giving up only 10 to 15 percentage points of efficiency compared to the absolute peak of modern aerospace engineering. And you are doing it for a fraction of the cost, using parts you can replace with a common wrench. However, this machine has hard boundaries where it simply will not work, and you need to know them before you spend a single dollar. First, let us talk about the wind itself. This turbine is designed for low to medium wind zones, what meteorologists call Class 2 or Class 3 resources. It thrives in steady breezes between 8 and 18 miles per hour. If you live in a deep, heavily wooded hollow in Kentucky, or a tight mountain valley in Tennessee where the trees block the air for half a mile in every direction, this machine will sit dead on its post. It needs clear, unobstructed access to the sky. You cannot mount this under the canopy of an old oak tree and expect it to light your home. You need to elevate it at least 15 feet above any roofline or tree line within 100 feet of the site. Second, understand the nature of the electricity it creates. A permanent magnet treadmill motor produces direct current, or DC. Direct current is like a heavy, viscous syrup. It does not like to travel long distances through wire. If your battery bank is located in a cellar, 300 feet away from your wind post, the resistance in that length of wire will consume your power before it ever reaches the terminals. Your battery bank must be close, ideally within 30 to 50 feet of the base of the tower. If you must go farther, you will have to buy incredibly thick, expensive copper cables, which completely destroys our $200 budget. Third, look at the climate limits. While the polymer of a food-grade drum is incredibly tough, it has an enemy: extreme, prolonged sub-zero temperatures. If you live in northern Minnesota or the interior of Alaska, where the thermometer drops to 40 below zero and stays there for 3 weeks, that plastic will lose its elasticity. A sudden, violent 50-mile-per-hour gust in the dead of winter can crack the frozen vanes right off their carriage bolts. In those extreme northern zones, you must replace the plastic barrel with sheets of galvanized roofing tin or aluminum, bent into the same precise curve using a log as a form. Finally, we must address the battery storage itself. The wind is a fickle partner. It will pour hundreds of watts into your system during a midnight storm when your lights are off, and it will give you nothing during a hot, stagnant afternoon. If you do not have a robust, heavy bank of lead-acid or golf cart batteries to store that harvest, the machine is nothing more than a spinning ornament. You cannot run a television or a pump directly off the wires coming down from the motor. The voltage spikes and drops with every passing gust would fry the delicate electronics instantly. The battery acts as a massive thermal sponge, soaking up the erratic spikes and releasing a smooth, steady, safe current to your home. This machine is an honest solution, but it requires an honest appraisal of your environment. If you have the clearance, the wind, and the right expectations, it is a tool that will outlast your expectations. But if you try to cheat the physics of distance, height, or storage, you will end up with nothing but a pile of plastic scrap and an empty wallet. Now that we understand the science and the limits, let us walk out to the fence line, clear the brush, and look at exactly how to secure the foundation so an autumn gale doesn't rip our work right out of the earth. Before we tighten the final bolts and watch this rotor find the current, we must remember that we are not the first to stand on a ridge looking for independence in the sky. We are merely uncovering a path that was paved a century ago, then deliberately overgrown with regulations and monthly bills. In the autumn of 1922, a Danish-American farmer named Marcellus Jacobs stood on a windswept ridge outside Vining, Minnesota, staring at a contraption he had bolted together for less than the price of a good milking cow. He used $200 in scrap wood, zinc plates, and old copper wire. When a 12-mile-per-hour breeze rolled over his pasture, that little machine spun up silently and lit every bulb in his farmhouse. At a time when the nearest municipal power line sat 43 miles away in a city he rarely visited, by 1931, his basic concept of decentralized, home-scale generation was outselling small, commercial solar experiments by a factor of nearly 20 to 1 across the rural Midwest. The proof of this method isn't found in a glossy modern tech brochure. It is stamped into the official records of our history. The United States Department of Agriculture quietly published Farmer's Bulletin, number 1394, a practical manual that laid out the exact wiring diagrams and mechanical tolerances needed for homesteaders to harvest their own power using standard shop tools. Look closely at this archival image of Marcellus Jacobs standing with one of his early chines. Notice the absolute simplicity of the frame, the direct drive mechanism, and the rugged tail vane. There are no delicate microprocessors up there. It was built to endure the elements, not to be replaced on a corporate schedule. In 1933, Admiral Richard Byrd took one of these simple Jacobs units on his historic Antarctic expedition. That machine, bolted into the frozen shelf of the most brutal climate on Earth, ran continuously for 22 years with zero maintenance beyond a single bearing change. The knowledge worked so well that it threatened the very foundation of the centralized energy grid. In May of 1935, Franklin Roosevelt appointed Morris Llewellyn Cook as the first administrator of the Rural Electrification Administration. Cook was not a villain out of a storybook. He genuinely believed that a massive, centralized grid was the only modern path forward for the nation. But the cheap federal loans and policies his office extended made it economically irrational for a regular farmer to spend a weekend maintaining his own wind generator when grid power arrived directly at his pasture pole for just $1.50 a month by 1956. The year Jacobs was forced to close his Minneapolis factory, 96% of American farms had been connected to the central lines. The bulletins explaining how to build your own system were systematically removed from agricultural extension offices. The practical wisdom moved from common sense to eccentricity. Once the utility companies captured the last independent homesteads, they began a slow, steady, century-long rise in rates that has brought us to where we are today. With the average American household paying nearly $1,800 every single year just to keep the lights on. But tradition has a way of surviving in the quiet corners. The grid was refused. The Amish builders in Wayne and Holmes counties never signed those utility contracts. They took the principles laid down by Jacobs, combined them with the vertical axis refinements published by the engineer Ed Lenz in the late 1990s, and kept the knowledge alive in their workshops. They proved that the tools of true independence do not require a factory cleanroom or a $20,000 bank loan. Stop and think about that. The wind that moves through your trees tonight is the exact same mechanical force that turned Jacobs' blades in 1922 and Eli's barrel rotor last autumn. The physics has not altered by a single fraction of a degree. The laws of electromagnetic induction are completely indifferent to whether a copper wire was wound by a multinational corporation or by your own calloused hands on a wooden workbench. This weekend, I want you to step away from the screen and the endless commentary sections. Drive down to a local farm auction, an estate sale, or a metal scrapyard. Look for that discarded treadmill motor with the thick iron casing. Find a blue polymer drum that someone has left sitting behind a barn. Bring them home. Clear off your bench. And pick up your tools. Do not let the complexity of modern life convince you that you are incapable of providing for your own hearth. The old knowledge is patient. It has been waiting for 70 years for men to realize that true security isn't something you buy on a 20-year lease. It is something you build with a wrench, a piece of scrap steel, and the patience to watch the sky. The air is already moving across your ridge, entirely free, asking for nothing but your time. Go out there, catch it, and bring your home back into the light.